Welcome to Section 9, Flow Control Statements. Up until now, our programs have executed sequentially, meaning one line after the other. Flow control statements give your program the power to make decisions and repeat actions, moving beyond simple, linear execution. This is what makes programs flexible. 1. Sequential flow. This is the default mode. Instructions are executed in the exact order they appear, from top to bottom. Every program we have written so far has followed sequential flow. 2. Conditional flow. This allows the program to execute a specific block of code only if a certain condition is true. It is the program's way of asking a question, like, if the user is logged in, then show the profile page. This is handled by if, elif, and else statements. 3. Iterative flow. This allows the program to repeat a block of code multiple times. This is perfect for tasks like processing every item in a list or running a process until a condition is met. This may be handled by for and while loops. To summarize, understanding these three types of flow control, sequential, conditional, and iterative, is important. We will now learn the first type of flow control, conditionals. Our next lecture 0902. If-else syntax. See you there. Welcome back. We begin our exploration of conditional flow with a fundamental if statement, which allows a program to decide whether or not to execute a block of code. We then introduce the else statement, which provides an alternative path if the if condition is false. 1. The if statement. The if keyword is followed by a condition, which must be a Boolean expression that evaluates to true or false. The line ends with a colon, and the code to be executed must be indented. 2. Indentation is crucial. Unlike many other languages that use curly braces, Python relies entirely on indentation, typically 4 spaces, to define a block of code. All lines belonging to the if block should be indented by the same amount. 3. The else statement. The optional else block provides a guaranteed path of execution if the if condition turns out to be false. Only one block, either if or else, will ever execute. To summarize, the if-else structure allows for binary decisions. You may use comparison operators for the condition, and remember that indentation is not optional. It is fundamental Python syntax. Now that we know the syntax, our next lecture 0903. Find even or odd number. Welcome back. In this exercise, we combine our knowledge of the modulus operator and the if-else statement to solve a classic programming problem, determining if a number is even or odd. This is a fundamental application of conditional logic. 1. Reading and preparing input. We first ask the user for a number. Since we need to perform arithmetic, we immediately cast the input string to an integer using the int function. 2. The modulus condition. A number is even if it is perfectly divisible by 2, meaning the remainder is 0. We use the modulus operator, the %sign, to find the remainder. Our condition will check if the number modulus 2 equals 0. 3. Applying if-else logic. We use an if-else block. If the condition number modulus 2 equals 0 is true, we print that the number is even. Otherwise, the else block executes, telling us the number is odd. To summarize, the modulus operator may be applied for checking divisibility. This exercise shows how a simple Boolean result from a comparison is used to branch the program flow, making a fundamental decision. We have seen binary decisions with if-else. What if we have more than two possibilities? Our next lecture 09 to 04. If-else ladder. Welcome back. While the basic if-else statement handles binary decisions, real-world logic often involves multiple possible outcomes, such as assigning a letter grade based on a score. The if-else ladder, or multi-way branching, may handle these scenarios. 1. The elif keyword. The elif statement is short for else if. It allows you to check a new condition only if the previous if or elif conditions are false. You can have any number of elif statements between the initial if and the final, optional else. 2. Flow and exclusivity. The conditions in the latter are checked strictly from top to bottom. As soon as a condition is found to be true, its corresponding block is executed, and the entire rest of the ladder is skipped. Only one block will ever execute. Because the first condition was true, the program immediately exits the entire conditional structure, ignoring the later, technically true, elif condition. 3. The final else. The else clause, placed at the end, is optional but highly recommended. It acts as the final catch-all, executing only if all previous if and elif conditions failed to be true. To summarize, the if-elif-else ladder may be for sequential decision-making. Order matters, as the program only executes the first true condition it encounters and then skips the rest. Now that we know how to handle multiple conditions, our next lecture 09 to 05. Handle 0. Welcome back. Good programming practice requires anticipating errors. One of many errors is the division by zero error. In this lecture, we will use the if-else statement to perform basic input validation, ensuring our program doesn't crash if the user enters 0 as a divisor. 1. Reading inputs. We need two numbers, a numerator and a denominator. Both are read as strings and immediately converted to floats to allow for decimal division. 2. The conditional check. We place the division logic inside an if statement. The condition checks if the denominator is not equal to 0. If this condition is true, we can safely proceed with the calculation. 3. Handling the error case. If the denominator is equal to 0, the if condition is false and the else block executes. Instead of crashing, the program gracefully prints a warning message to the user, explaining the problem. This simple structure protects your program from a runtime crash. To summarize, you should validate input where potential errors exist, especially for division. You may use an if-else structure to specifically check for and handle the invalid case. We have now learned conditional flow. Next, we move to the second type of flow control, iterative flow. Our next lecture 09 to 06. while syntax. Welcome back. We are now going to iterative flow, which allows us to repeat code. The first structure is the while loop. It executes a block of code repeatedly as long as a specified condition remains true. 1. The syntax and flow. The while keyword is followed by a Boolean condition and a colon. The code block below it is indented. The program checks the condition. If true, it executes the block. It then returns to the top and checks the condition again. This loop continues until the condition evaluates to false. Two, controlling the loop. While loop may require a mechanism inside the loop body to eventually make the condition false. We call this the update statement. In our example, the line incrementing count ensures the condition count less than 3 eventually fails. 3. Infinite loops. If you forget or accidentally omit the update statement, the condition may never become false. This creates an infinite loop, causing your program to run forever, or until the system stops it. For example, if we removed the line count equals count plus 1, the program would constantly print loop iteration 0. To summarize, the while loop is excellent for repeating actions when you do not know the exact number of iterations beforehand, such as continually asking the user for input until they enter a valid response. Our next lecture 0907. Display numbers from 1 to 20. Welcome back. Let's put the while loop syntax into immediate practice. Our goal is to print all numbers starting from 1 up to and including 20. This exercise clearly demonstrates the 3 parts of a while loop: initialization, the condition, and the update. 1. Initialization. We need a counter variable to track our current number. Since we start at 1, we initialize the variable count to 1 before the loop begins. 2. The loop condition. We want to include 20. Therefore, the loop must continue while the current value of count is less than or equal to 20. If we used only less than 20, the loop would stop at 19. 3. The loop body and update. Inside the loop, we first print the current value of count. Immediately after, we use the increment update statement, count equals count plus 1, to prepare for the next iteration. Forgetting this line leads to an infinite loop, repeating the number 1 forever. To summarize, iterative programs should be careful definition of the start, end, and step size. This pattern is foundational for many sequence generations using the while loop. Our next lecture 0908. Odd numbers between given numbers. See you there. Welcome back. This exercise will apply something we've learned related to flow control. Our goal is to ask the user for a starting number and an ending number, and then print only the odd numbers within that range. This requires both the while loop for iteration and the if statement for decision-making. 1. Reading and initializing inputs. We read the start and end numbers from the user. Since the end number defines our loop condition and the start number acts as our initial counter, We assign the start input to our control variable, which we will call current_number. 2. Combining while and if. The while loop runs as long as current_number is less than or equal to the end value. Inside the loop, the if statement checks for the odd condition, if the number modulus 2 is not equal to 0. Three. Analyzing the flow. Notice the indentation. The if statement and the increment line are both inside the while loop. However, the print statement is only inside the if block. This ensures that the number is increment every time, but only printed when the odd condition is met. To summarize, combining loops and conditions is a programming pattern that you may use regularly in the future. The while loop controls the repetition, and the if statement controls which data points are selected or acted upon during that repetition. We have seen the while loop. Next, we explore the for loop, which is often easier to use when iterating over a known sequence. Join me in Lectures 09 for syntax. Welcome back. While the while loop is great for repeating actions based on a condition, the for loop is the preferred method in Python for iterating over a sequence of items, such as a list of names or a defined range of numbers. For predetermined ranges, it is simpler than while. 1. The basic for loop structure. The for loop automatically manages the counter and termination. You simply tell it to execute the code block for every item in a sequence. Python handles the rest. 2. Iterating with range. Maybe you need to loop a specific number of times. Instead of manually creating a list of numbers, Python provides the built-in range function. This function generates a sequence of numbers, which the for loop iterates over. 3. The step parameter. The third, optional argument in the range function is the step size, which determines the increment or decrement between numbers. This allows you to count by twos, or even count backwards. To summarize, the for loop simplifies iteration over sequences. The range function, it lets you easily define the start, end, and step for numerical loops. Our next lecture 09-10. Using for loop. See you there. Welcome back. In this short practical exercise, we will immediately apply the syntax of the for loop and the range function we just learned. The goal is to generate simple number sequences, demonstrating how easily the for loop handles a fixed number of iterations. 1. Simple range. When you provide only one argument to range, it is treated as the stop value. The loop starts by default at 0 and goes up to, but does not include, the stop value. We will print the numbers 0, 1, 2. 2. Custom start and end. Here, we specify both the starting point and the stopping point. We want to print numbers from 5 to 8, so our range function must stop at 9 to include 8. 3. Using the step parameter. We can use the third argument to define a step size. Let's print the odd numbers from 1 to 10 by setting the step to 2. 4. Counting backwards. The step can also be negative. To count down from 5 to 1, we set the start to 5, the stop to 0 to include 1, and the step to -1. To summarize, the for loop combined with the flexible range function is a readable way to iterate a fixed number of times in Python. Now that we can loop through numbers, let's use the for loop to process data collections. Our next lecture 09.11. Product of numbers in a list. Welcome back. You can apply loops to process collections of data, such as lists. Our goal in this exercise is to find the product, or the result of multiplying all numbers stored in a list. This requires setting up an accumulator variable and iterating through the list using a for loop. 1. Initialization and accumulator. We start with our list of numbers. Crucially, we must initialize a variable called the accumulator to hold our running product. Unlike calculating a sum where the accumulator starts at 0 for a product, the accumulator must start at 1 so that the first multiplication yields the correct result. 2. Iterating and updating. We use the for loop to iterate directly over the list. In each iteration, the loop variable, which we call number, takes the value of the next list element. Inside the loop, we multiply the current value of product by number and store the result back into product. Three. Final output. After the loop completes all iterations, the product variable holds the final result, which we display using an f string. To summarize, for this pattern, you need to correctly initialize the product accumulator to 1. The for loop then systematically updates this accumulator with the result of multiplying the current value by the next list item. Our next lecture 09.12. Multiplication table of a given number. See you there. Welcome back. This lecture is related to generating a multiplication table. Our goal is to ask the user for a number and then print that number multiplied by every integer from 1 up to 10. This requires combining user input, the for loop, and f-string formatting. 1. Receiving input and initialization. We need to get the number from the user for which we are generating the table. We immediately cast this input to an integer. A multiplication table may run from 1 to 10. In this lecture, we will use the range function. 2. The for loop structure. To loop from 1 to 10, we use range 1, 11. The loop variable, which we call I, will take the values 1, 2, 3, and so on up to 10. 3. Calculation and formatting output. Inside the loop, we calculate the result of the multiplication, n times I. We use an f string to display the entire equation clearly, showing the original number, the multiplier, and the result. To summarize, this exercise applies simple arithmetic inside a structured for loop, combined with careful range definition, can quickly generate detailed, repetitive output, like a multiplication table. We have now learned standard looping. Our next lecture 09.13. Break. See you there. Welcome back. Sometimes, we need to stop a loop prematurely, even if its main condition is still true. The break statement is used to achieve this. It gives you an immediate exit from the innermost containing loop. 1. Break syntax and flow. The break statement may be used inside an if statement within a loop. When Python encounters break, it skips the rest of the loop's current iteration, ignores the loop's main condition, and moves execution to the first line of code immediately following the loop. 2. Practical use case, searching. You may apply break to search for a specific item in a large collection. Once the item is found, there is no need to continue looping through the remaining data, so we break to save time and resources. 3. Comparison with loop condition. If the loop was defined as for I in range 1 to 10, it would normally run 9 times. However, because of the break at I equals 5, the loop only runs 5 times. The break takes precedence over the loop's inherent termination condition. To summarize, the break statement is a powerful tool for efficiency and handling conditions that require immediate termination of a repetitive task. While break stops the loop entirely, sometimes we only want to skip the current item and move to the next. Our next lecture 09.14. Continue. Welcome back. While the break statement immediately terminates a loop, the continue statement serves a different purpose. It skips only the remaining instructions in the current iteration of the loop and immediately proceeds to the next iteration. You may apply it to skip certain data points. 1. Continue syntax and flow. Similar to break, continue is typically placed inside an if statement within a loop. When Python executes continue, it ignores any code that follows it inside the loop body for that specific iteration, and then immediately goes back to check the loop's condition and start the next iteration. 2. Practical use case, data filtering. You may apply continue to filter out invalid or unwanted inputs. In this example, we only want to process positive numbers and skip 0 and negative numbers. 3. Continue versus break. Remember the key difference. Break stops the loop entirely, executing the code after the loop. Continue only stops the current step and forces the loop to proceed to the next element or iteration. To summarize, you may use continue when you want to bypass the main logic for a particular item but need the loop to keep processing the remaining items in the sequence. Our next lecture 09.15. Assert. See you there. Welcome back. The assert statement. It is a debugging aid used to test assumptions about the state of your program. If the assumption is false, Python immediately halts execution and raises an assertion error. 1. Assert syntax. The assert statement takes at least one argument, a condition that must be true. Optionally, it can take a second argument, which is a message string displayed if the condition is false. 2. Handling a failed assertion. If the condition is false, the assertion fails. The program stops, and Python raises an assertion error. This is intentional. It signals that something unexpected and critical happened, requiring developer attention. 3. Assert versus if. A if statement may be used for checking expected conditions and handling them gracefully, for example, printing an error message to a user. Assert is strictly for developer use. It validates internal assumptions and should never be used for user input validation because it is designed to crash the program when something is fundamentally wrong. To summarize, use assert to confirm conditions that your code must have to function correctly. It acts as a safety net during development and testing. We have learned the fundamental flow control statements. Our next lecture, 0916. More programs, remove duplicates in list. See you there. Welcome back. We are now moving into programs that combine something we've learned. Our first problem is removing duplicate elements from a list. We will achieve this using a for loop and conditional logic without relying on advanced data structures like sets. 1. Setup and initialization. We start with a list containing duplicate numbers. We must create an empty list, which we'll call unique_list, to store the elements that pass our uniqueness check. This empty list is the key to tracking items we have already processed. 2. Iteration and condition. We use a for loop to check every element in the original data_list. Inside the loop, the if statement performs the check. Is the current number not in the unique_list already? The not in operator is perfect for this type of membership check. 3. Result display and analysis. The final unique list is now ready. The crucial logic here is that the unique_list grows with unique items, and the not in check uses this growing list as a historical record to decide whether to admit the current number. To summarize, removing duplicates by manually checking for membership in a secondary list is a classic looping pattern. It is a demonstration of using a loop to get a filtered collection of data. Our next lecture, 0917. More programs, count vowels in a word. See you there. Welcome back. In this exercise, we will apply flow control to text processing. Our goal is to write a program that accepts a word from the user and counts how many vowels it contains. This involves iterating over a string and using membership operators. 1. Initialization. First, we define the word we want to analyze. Then, we define a string containing all possible vowels, both lowercase and uppercase, to act as our reference. Finally, we initialize a counter variable to 0. 2. Iteration and checking. We loop through every character in the word. Inside the loop, we check if the current character exists within our vowels reference string using the in operator. If it does, we increment our counter. 3. Displaying the result. Once the loop finishes checking every character, the count variable holds the total number of vowels found. To summarize, this pattern of iterating, checking membership, and incrementing a counter is an approach for analyzing the content of strings in Python. Our next lecture, 0918. More programs, handle employee details. See you there. Welcome to our final program for the flow control section. We will combine loops, user input, and lists to create a basic system for collecting and displaying details for multiple employees. 1. Setup and control loop. We create a master list, employee_data, to hold all records. We use a while true loop to repeatedly ask for input, providing an option for the user to break the loop when data entry is complete. 2. Collecting data. If the loop continues, we prompt the user for the employee's name and salary. We convert the salary to an integer, then package this data into a new list structure, representing a single employee record. 3. Displaying collected data. After the while loop breaks, we use a separate for loop to iterate through the main employee_data list. For each record, we neatly print the collected name and salary. To summarize, this program uses a while loop for unknown iteration counts, like repeated input, and then uses a for loop to process the structured data collected in a list. This concludes our section on flow control statements. Our next section is 10 more programs 2, starting with lecture 10.01. Reverse a string.